Hello everyone. In this video, we're going to be simplifying an exponential expression with natural logs. We have e to the power 2 to the power ln 2 divided by ln 2. And we're going to simplify this expression. We're going to write it in the simplest form. So before we start simplifying this problem in two different ways, I just want to talk about one thing that is very important because a lot of times this is misunderstood. Whenever I write something like a to the power b to the power c, some people say that this is ambiguous, which is not true, because this is meant to be a to the power b to the power c, not a to the power b and then that to the power c, because this is basically a to the power bc and they are different things, right? So let's make that clear first. We take this to be the base and this to be the exponent first, and whatever that answer is, we do e to the power that number, okay? So let's go ahead and see how we can simplify this in two different ways. And to be able to simplify something like this, I'm going to go ahead and focus on the exponent first. So let's go ahead and focus on this, and we've done a similar problem. You'll hopefully go ahead and take a look at that problem. It's recent, so hopefully you can find it, and in a more general way we did that problem. So we have 2 to the power ln 2 divided by ln 2. So notice that we have the two, a lot of 2's here, so that should hopefully simplify. And also we have the natural log. So the first method that I'm going to use uses change of base with logarithms. So let me talk about that real quick. Whenever you have something like log a with base b, you can write it as log a over log b. Here the base is not specified, but you can basically use a generic base like x. So this is called the change of base formula. You can abbreviate as, I guess, COB, and then, or COB. And here's how you can apply it to the natural logs, because in this case, we're talking about the ratio of two ln's. So it would make sense if we wrote the version of the formula with ln's, which would be easy to do, ln a over ln b. Make sense? The b always is going to be the base, so it's going to be in the denominator. A is going to be in the numerator. So how do you apply that to this? So we're even taking that apart and just focusing on the exponent of 2. And now, if you take this to be a and this to be b, this would be ln a over ln b, which is log with base b of a. Make sense? And what is that? It is log base 2 of a, which is ln 2. Okay, that doesn't look very good, but at least we got something out of it, right? At least it's not a quotient. So now we're going to go ahead and plug it in. And if you want to write this ln 2 is parentheses, be my guest. But now let's go ahead and do it 2 to the power that. So 2 to the power ln 2 over ln 2. Since I got this for the exponent, it's going to be 2 to the power log of ln 2 with base 2. Okay, how do you simplify this? We're going to use another property of logarithms, right? There's a lot of properties you need to use. You need to be familiar with those. But let me tell you something. Whenever these two numbers are equal, then the answer is this, the argument of the log function. Make sense? In other words, whenever you have something like a to the power log b with base a, the answer is b. Make sense? So this would be, in other words, this 2 and that log base 2 cancel out, leaving us with ln 2. Okay? But that's not the answer, because remember, the original problem gave us e as a base, that was the exponent, and then we looked at the exponent of the exponent, whatever that means. So now we have the following. E to the power ln 2 is what we have, because the big exponent became ln 2. So now e to the power ln 2 is equal to 2. As you should know, e to the ln x is always x, because those are inverse function, the exponential and the logarithmic function. Okay? Makes sense? So in the simplest form, this is 2. What is that? It is e to the power 2 to the power ln 2 divided by ln 2. And to be able to prove this property, like if you're not familiar with this and you really wanted to see the proof of it, you can basically do the following. Let me show you how that goes. Set it equal to x, and then log both sides with base a, and then from here, you should get the answer because this is going to move, this is going to be 1, so on and so forth. Okay, makes sense? So you go ahead and try to prove that by yourself. That would be a really good exercise. Now let's go ahead and talk about the second method. Okay, so the second method for this problem is going to go as follows. Let me rewrite the original problem one more time. E to the power 2 to the power ln 2 divided by ln 2. Of course, you don't have to do it that way. There's a lot of different ways to do it. And do we really have to isolate 2 to the power something first? Can we not look at the whole thing? Yes, we could. For example, one of the ways you can approach it, and this is not necessarily the second method that I just want to talk about real quick, is that you can set it equal to x and then start natural logging both sides. And when you natural log both sides, you're going to get something nice. Like what? This is going to be ln and this is going to be ln. And this whole thing, remember this was the exponent, right? You're going to have to bring that down. 2 to the power ln 2 over ln 2 times ln e, which is 1. So you don't even have to worry about it. This should be ln x. And guess what? You could ln both sides one more time and keep doing this until you get something concrete, right? If you ln one more time, it's going to look like this. This will move again. That's the only way basically to move it to the front. You have to log both sides, and ln seems to be working well in this case. And now these two are going to cancel out. And I think this could be qualifying as a second method. Maybe we can even talk about a third method. I wasn't planning on initially, but notice that it really simplifies nicely. And it's probably an easier way to do it because notice that ln x is ln 2, so that means x is equal to 2. But the question is this the only solution? And the answer is yes, because of the log function. If you think about it, it's 1 to 1, always increasing for the natural log, and this is 1 at the x-intercept. And as you know, there's an asymptote, right? So yes, x equals 2 would be the only solution. Now, could we really think of a third way to do this problem? Let's quickly explore before time runs out. Okay. I mean, we have infinite time, but if the video is way too long, I know some people are kind of discouraged. Anyways, so another way to look at it is take this expression, 2 to the power ln 2 over ln 2, and then kind of set it equal to something. You know, there's, again, a lot of ways to do this. You can even start with this like, okay, I want to set this equal to a, or x, whatever, doesn't matter. And then you can go ahead and cross multiply. It's going to be a times ln 2. And then you can kind of move this here. That will be ln 2 is ln 2 to the a. And then from here, you're going to get 2 to the a is ln 2, right? And then to solve for a, you can kind of do something about it. And then you can plug it in, or even think about it this way. Wait, this was 2 to the power a, and 2 to the power a just happens to be ln 2, and then just plug it in here. If this is ln 2, then the whole thing will become 2 again. So no matter how you do it, the answer will always be 2, okay? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. Oopsies. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.